very old ultimate science. It's science with Black Mr. Griffin and the other guy. It's science! Yeah! Woo!
Earthquakes.
Okay, I fell out a window.
Yeah.
Yeah. That was a lot of weird dirt.
I mean, not because of the earthquake, I just fell out a window.
I'm guessing the reason that earthquake happened is because we're sitting on a fault. Because earthquakes happen at faults.
So that's what they mean by fault. That's an area where earthquakes can happen.
Makes sense.
Well, you know, and technically a fault is a fracture in the earth because there's a lot of rock below us. Okay.
Okay.
It's sometimes where plates actually meet, but not always.
Okay.
'Cause, I mean, for example, we've had earthquakes around here.
Yep.
You guys
There's no
remember one,
plate
like, 6
meeting
years
underneath
ago?
us.
Yeah,
Yeah.
we're right smack dab in the middle of North American plates. So there can be faults even on a large in the middle of
So
a
a fault
plate.
is a break in the rock, and usually it results in an earthquake.
Yep.
Okay.
So
Are there different types of faults, or is
yeah,
there like one?
that's what we're about to learn about. There's 3 of them.
2,
okay.
3. Let's look at
Sometimes I
them.
amaze myself.
So here's the key, though, in understanding faults. With faults, you have what's called a foot wall and a hanging wall.
Okay.
The foot wall, here, pretend my hands are 2 sections of rock.
Okay.
The foot wall is the one that you can almost imagine stays in place.
Okay.
Okay.
It's kind of angled up like this.
Okay.
Now the hanging wall is one that's going to either move towards or away from the foot wall.
Okay.
Okay.
All right.
On that picture, the foot wall is the one that's kind of higher up because
Okay.
it kind of looks like a foot. It kind of juts
Okay.
out like it has toes. Okay. But anyway, and the hanging wall, hanging block mean the same thing.
Okay.
So anyway, in a normal fault, that's when it happens at divergent boundaries a lot, and
So
it pulls
move it
apart.
away.
Okay? Now that hanging wall gets brought down by gravity. It just kind of goes downwards.
Okay.
And as it goes downwards, the 2 pieces of rock kind of rubbing against each other, that's what causes the shaking.
So it's that grinding, that like.
Yeah.
That's what makes it
Okay,
shake.
stop, stick
And
kind of thing.
normal, we can kind of think of it follows the normal path of gravity downwards.
Yep.
Okay.
Okay.
Sense.
Whereas the opposite is called a reverse
Reverse fault. So normal is when that hanging wall drops. Reverse fault is when the hanging wall actually scooches up, still
Yep.
shakes, and moves
Yep.
up
Okay.
over the
You
foot
can see it
wall.
really well in that picture how there was like, especially I see those tan and that one kind of wavy one
I can
got
see
pushed
it.
up. Now that part's the hanging wall.
Okay.
That or hanging
That looks
block.
dangerous.
That got pushed upwards because it's
Okay.
reverse fault. This usually happens when there's conversion forces pushing.
So push them
Okay, so
together,
the
and
push-
one kind of
As it
ramps
gets
up
pushed
over
up,
the top.
Yeah, one gets kind of pushed over the top, and that rubbing that happens there, that's what causes all the
There it
force.
is.
Makes sense.
Again.
It makes sense if you think about it too. Divergent just makes sense that one's going to kind of slide away, whereas convergent makes sense one's going to push up over the other.
Yeah.
So it's
sense
just
to me.
rocks grinding against each other that cause
Yeah.
that shaking, and it's the
Yeah.
energy released.
And then the last type is the strike slip. Okay, and this is when you have shearing forces tearing apart 2 blocks. So shearing would be like when they're like dragging across next to each other. And what happens is you build up this energy, you build, and all of a sudden, poof, it releases, and that's where the earthquake happens, is they slip past each other. And you usually find that with transform boundaries, which, as we talked about before, is sliding past.
Like, look how the lines look like they're shifted in that
Yep.
picture. I get it. Okay,
Yeah.
so it looks like they're not lined
It's
up
actually a
anymore, like
different
the
farm
ground
picture than last
shifted.
time, too.
Yeah, it's not the same one.
the same
It's
one.
not the same one, but again, another example of you can see the
Wait,
lines.
You
and they
mean that
shifted.
these faults occur in more than just one place?
Yeah.
Oh,
Yeah.
Oh,
wow.
interesting.
This is actually in LA, where in the earthquakes, it's usually a strike slip fault.
Yep.
Pretty sure.
Yep,
So,
yep.
Anyway, now we're gonna actually get into earthquakes.
Okay, so earthquake terms. The first thing you guys should know is there's this thing called the focus. That's the point in the earth where the actual earthquake occurs, where the actual break happens. That it's down in the earth. It's not at the surface.
Oh, so earthquakes happen really deep.
Oh.
Yeah, really deep.
Okay, I always thought they happened on the surface.
No, we feel it on the surface because that's where we live, but the actual earthquake starts in the earth down at this area called the focus. And when the rock breaks or moves or slides past each other, there releases a lot of energy, and it kind of radiates out like in a huge, huge burst of energy,
Okay.
like rock thrown into a pond. And as it comes up, if it hits the surface directly above there, above the focus, you have this area called the epicenter, and that's
okay.
where it actually strikes the surface. And we first can say directly below the epicenter is the focus where it happens. So earthquake happens at the focus, and the epicenter is a point directly above it
Got it.
that we measure the earthquake's epicenter at. This is where it first breached the surface, if
That's
we want to
where
call it.
where we find it.
Yeah.
Got it. Cool. So,
Ooh, waves.
yeah.
I remember that.
I love
We talked about waves
waves.
for a while now. When an earthquake occurs, that energy gets released. It moves to the surface and elsewhere in waves. So there's 3 types of waves that we're going to talk about. Now, before I even go there, what does the word primary mean?
Primary's first.
Yep.
It's got to be first.
And secondary means
Secondary second.
Second.
Oh,
yeah,
yeah.
what it's
Math
called
for the
surface
win.
waves, L waves. We're actually kind of oversimplifying the surface waves or L waves in this class.
Right.
It's a little more
Yeah.
complicated than what we're going to say, but for the sake of this class, we'll say there's a 3rd type of wave called surface waves.
Okay.
But anyway, so the primary waves are a longitudinal wave. It compresses certain areas of rock and spreads out certain areas of rock as
Okay.
the energy
Very
flows
mechanical.
through. Okay, and primary waves can move through solids, liquids, and gases.
That seems important.
All 3
Yeah.
of them.
Primary waves will move through any medium.
Yep.
That seems important.
Yeah.
They travel underground.
Do you think maybe we should write that down?
I would. I would. I'm doing it right now. Hold on.
As I speak. Wait, you know what? Yeah. Got it.
Got
Good.
it. We're good.
Now, while they can travel through anything, they're actually the least destructive.
Yes.
They don't
Okay.
cause much damage. Like, you can kind of, unless it's really, really strong, the earthquake.
Unless you're right at the epicenter
You usually
of it.
don't even feel the P waves very
Yeah.
often.
Okay.
Now,
When you have one of those,
seismograms.
Thank you.
Our machinery can
I was
pick up the
forgetting
P
it.
waves. P waves come first.
Mm-hmm.
They're the first little indications like, whoa, something's going to happen. So like what just happened to us at the beginning of this video, that was probably like maybe secondary waves or later waves, right? P waves we wouldn't have felt.
Right.
yeah.
Okay.
Now, after P waves, what do you think there are?
Secondary.
Secondary. So secondary waves are the second fastest waves, so they reach you second. They're transverse waves, so if you remember transverse, yep, there you go. They go up and down.
It's like that S wave is all wavy on there. You see the picture?
Yeah. Interesting
Right
thing
over
about
there.
these, though, is they can only move through solids. So they can't move through liquids or gas, which is kind of weird.
Yeah.
But it's true.
But S wave, solid, S shaped.
But they'll still be
secondary.
traveling underground, and they're much more destructive
Yeah.
than primary waves are.
Because now they're buckling. Like if you took a blanket and snapped it, the blanket goes like that. It's going to start to
Yep.
flip stuff
But if
around.
they hit an area of liquid, they stop.
Yep.
Which is kind of cool.
But we're talking earthquakes, so let's get to the real bad boy of earthquake waves. Take it away,
Those are the
Mr.
surface
Carnstead.
waves. Also, those the L waves, because I think the scientist's name was Love.
Love.
Yep.
The love waves bring
love
nothing
wave.
but hate.
Yeah, love waves seems like a weird thing to talk
Yeah,
about.
because
love
these
wave.
are the ones that will wreck your day.
So they take a while to get to the surface, and they're actually a combination of when the primary, because the primary wave keeps happening, it keeps pushing,
Yep.
pushing, pushing.
Yep.
Then the S wave gets up there, and then when they combine and interference happens.
Positive,
So
constructive interference.
You get destructive.
you get
Yeah,
these
you'll
very
get the
destructive
push.
waves, okay?
Yeah.
So you get this very, like, just intense, violent wave.
We will do this in class with
And
that
they-
super big slinky.
Yeah, and this really only
Slinkies are
happens.
fun, too.
This really only happens at the surface. This doesn't happen underground.
Right.
It's
Yeah.
actually- yeah.
So
Alright.
in terms of intensity, we have
Yeah.
a way to measure it, and conveniently enough, we have this wonderful thing called the Richter scale, which was invented by a dude named Richter.
Yes.
And
We'll
it's
talk about
basically
that
a
class.
logarithmic
Scale?
scale. I don't
No.
think so.
Okay.
No, I think it was Richter.
We'll go over
And
it,
so it's a
guys.
logarithmic scale, which means it's exponential. So when you have like a magnitude 1 versus a magnitude 2, which we'll talk a little bit more about, basically it's not just like, ooh, 2's a little bit more. It's like order of like 10 times
10 times
more.
worse. It's
a lot
not
stronger.
double. It's
One-
10 times worse.
One with a Richter scale rating of 3 is 100 times worse than
100
one.
times
than
worse
one.
than a 1.
I still remember my relatives. There was a 5.3 earthquake, I believe, when I was in college.
Wow.
So, really long time. Actually, it wasn't that long ago. But I was in college when it happened, and I remember I called up my cousins who live in Seattle.
Yeah.
I was like, we had a 5.3 earthquake. Wow. And then I remember they had lived through like a 7.2 or something.
Oh
and
my
they were,
God.
You're like,
and they were like, yeah, we got one. And I was like, well, it's only 2 higher, right? They're like, no,
No.
it's 100 times.
Yeah, it's 100
Yeah.
times more than
Which is
that. And we'll show you guys the scale and what it means in class, like general destruction level of
Right.
like a 5
It's
and a
actually-
6 and a 3
Although
and a 9.
if you can't wait, here it is right here.
Yay!
Yay, I remember all that.
We're not
So
going to
it's-
sit here and read through it, but you
No.
can see,
Yeah.
obviously, is the higher you get, the more destructive it gets.
Yeah.
This
My
is
favorite
pretty
is
cool.
number 10. I like
10.
to call it epic.
Yes.
Never recorded, epic, extremely rare. That would be a purple drop in World of Warcraft.
Yeah.
Ooh, very true.
All right.
I don't know what you're talking about.
Earthquake damage.
You're better for it.
Basically, amount of damage in earthquake depends on a few things. First off, how deep it hits. Okay, so first, how deep the earthquake actually occurs. If it's very, very, very deep down in the earth, it may not have a whole lot of force when it hits the surface. If it's
Right.
close to the surface, a lot of that energy is going to burst up through the crust and it's going to wreck stuff.
Mm-hmm.
If you've got very high quality buildings, well-structured buildings, buildings that are built to sustain this kind of shaking, you may not get as much destruction.
Yeah.
In a more populated area, with bad soil and bad buildings, like say Haiti.
Yeah, the
Yep.
one that happened a few years
The
ago.
one that happened a few years ago was devastating, primarily because of how many people were packed in there, the structure of the
And-
island and the location there, and the buildings are very, very
The
poorly
overall
constructed.
conditions.
Its
bad.
Richter scale rating wasn't even that high.
It wasn't, but
Yeah.
because so many people were there and everything just like was kind of really bad for that.
So,
Yeah.
right. A way to think of it is Richter scale is kind of like the base, like the nuts and bolts description of the damage,
Yeah.
and then the other stuff is more the humanistic, like what's actually happening out there in the real world.
Yeah,
So-
think of it like how much force they put into it. Like you can knock over somebody who's small, like Mr. Black, with a regular
Oh,
push.
thanks.
It takes more force to knock someone huge like me over. So
True.
just think about it like that.
So now, often we hear about if earthquake occurs in the ocean,
Yep.
really big one, it can cause a tsunami.
Japan.
And the reason that, in Japan, I believe there's one in.
There's one in India. There's been
Indonesia.
Indonesia.
Indonesia had a big
something
one just
quite
recently.
So
Yeah.
the reason why this happens is because part of the ocean floor when an earthquake happens pushes up.
Okay.
Okay. And if you have suddenly an amount of solid that pushes up into a bunch of
Amount of
liquid,
liquid.
it's going to push that liquid
Right.
up
Liquid's
and
gonna
make
go
this
up.
giant bubble at the top. And then that's what then becomes this giant wave that then spreads. It goes for a long time. Like you can watch this go across the
Oh
ocean.
yeah.
So anyway,
I could see it coming in. It's-
yeah, because I remember even there's a big earthquake 3 or 4 years ago in Japan,
Yeah.
and I remember even like they predicted like 2 or 3 hours from now it's going to be hitting Hawaii, and I remember
Yep.
watching live when
Yep.
it finally
And it
came
hit.
in Hawaii. So it can travel all the way across. Japan and Hawaii are not that close.
No. Go
An
across
easy
the
way
ocean.
where you can see this though is if you've ever been in a wave pool. That's how wave pools actually make their waves.
Yeah, they put.
Yeah, they generate
push-
from underneath. There's blades that move underneath there like a
Yep.
panel, and
Water
it'll
goes
generate
up,
that
water
wave.
come down, big wave.
Yep. And I believe that is it because we're actually going to talk about this in class.
Yeah, seismic risk is where we're going to start to plan out what would you do.
All right, so we'll take that off. So, yeah, have a good day. Do
Later.
a checkpoint.
Checkpoints.
Be careful of earthquakes.